order, like in terms of who you're sending things to, you can send a message to all panelists, or you can send a message to all panelists and attendees. Wherever possible, please share with all attendees so you guys can communicate, get to know each other, and work together on your journey of learning Python. We'll be starting in approximately 2 minutes. Okay, we're going to give maybe 30 more seconds and then get started. Okay, welcome to everybody who's here on our first webinar. Thank you all for making this time work and joining us this week. I really do appreciate you taking the time to join this session. So I want to quickly go over some logistics as we get started. If you haven't attended any of our webinars before, please keep an eye out that there are 2 different ways in which you can communicate. There's a chat, which is a great way to communicate with other folks in the class, discuss things as we're going through the webinar material. And there's also a Q&A section. The Q&A section is where I'm actively going to be monitoring your questions about the materials that we're covering. I may ask you guys some questions along the way. Feel free to drop your answers in the chat. But if you have any questions that you'd like me to take time throughout the duration of this webinar to answer, please do so in the Q&A section. Like I will be setting aside time periodically throughout the duration of this webinar to make sure that your questions are answered. And my first question to you, first of all, thank you again for attending. I saw a few of you introduce yourselves in the chat. And my request to you is just let me know, like, is this your first time using Python? If you've used it before, let me know how. And just whether or not like you've been able to install it on your local environment, whether you've used it before or if you've literally never touched it. And all of those answers are fine, by the way. So if you're answering, communicating in the chat, please keep an eye out that there's a blue bar under like who the message is being sent to. If you want the message to be seen by everybody in this webinar, please send it to all panelists and attendees. Otherwise, I'll be the only one seeing it. Okay, awesome. So it seems like we have a range of folks who've some experience working with Python or similar environments and some who haven't. So we are going to be starting very much from the basics in this webinar and primarily focusing on getting started with the tools that you need to start using Python in your day-to-day work. And we're going to primarily be using Jupyter Notebooks for the duration of these webinars. So this is an important tool for you to get comfortable with, understand how it's important in the Python environment, but we'll also cover some other key tools that you could be using, namely around the Anaconda distribution, Spider. There are quite a few ways in which you can learn and use Python, and whatever works best for you is totally fine, but we're just going to focus on a small number of those types of ecosystems for the duration of this course. So quick overview. What we're going to be covering in this session is a little bit of a history of Python, just how the language came to be, why it's important, why it's so popular now in data science. And then we're going to cover the installation of several pieces of key software that we'll be using throughout the duration of this webinar. Namely, we're going to install Anaconda. If you jumped on early, you may have noticed that I was reinstalling it. We're not going to actively do it throughout the webinar because it is a very large package, but I do encourage you to follow along and download all of the packages that the distributions and software that we're covering as we go along, because these are the tools that really will allow you to use Python in your day-to-day work. And then we're going to cover just some basics of what Python syntax looks like, what the data types are, just get you familiar with what is available in Python. And I'm sure many of you with different programming languages have seen the like Hello World tutorials. We're going to go a little bit into how those types of tutorials and basics are really the building blocks for everything that we're going to learn later on. Okay, so brief history of Python. Python is not named after the snake. It is named after Monty Python's Flying Circus. The creators of the Python language thought it would be silly. And if any of you have seen any Monty Python movies or skits or anything, they are pretty funny. And a lot of those I think are like the humor and the like criticism and whatnot, I think in some ways did guide like how Python was developed as a language. So it was first published, just made like publicly available as a programming language in 1991. Python 1.0, so like the first like actual release of like, this is Python, everything's available, was released in January of 1994. And we've got a cute little timeline here, just giving you a sense as to how Python was developed over time. I think in many cases, over the course of a lot of the lifetimes of many of the folks who are actually here now on the webinar, Python's been available and in development for quite a while at this point, like going on 25 years, I think. And there have been major releases pretty much every couple of years. So this has been a language that's been actively worked on, improved, made available to different audiences for different purposes. And the Python that we're actually going to be using that you're probably going to get fairly familiar with is Python, we say 3.x, and that's because there are major differences between Python 2.7 and 3.2, which was the next release that makes them not quite compatible. And Python 2.7 is actually set to be retired in 2020. So if you've ever worked at any organization that's used older versions of Python, many of them have been holding on to that old code and not been updating it to Python 3. A lot of folks that I know that are working in different types of companies are actually spending a lot of time and money updating code from Python 2.7 to 3 point something. And we're up to Python 3.x is the latest. We're up to 3.7 point something, and we're actually going to go over that in the downloads, but there aren't any like major compatibility issues between, say, like Python 3.5 and Python 3.7. And yeah, that's pretty much what the history of Python has looked like. There are a number of key features that were considered as the language was being developed. It was specifically designed to be as simple as possible and human readable. So most of the keywords in Python, as you'll notice as we go through this course, are keywords that are in English. Code blocks are denoted using indents. So you do like a tab indent if you have a block of code that all executes at the same time, as opposed to maybe brackets or a gazillion parentheses. Like Python forces you to write neat code in a way that many other languages do not. And many of the expressions are similar to other languages. So if you have experience with any other program languages, first of all, let me know in the chat. We had one person who let us know that you've had experience with Java. If you've ever coded in any other type of language, do let me know. It's something I can keep in mind as we're developing the webinars over the course of the term for this course. And yeah, so Python is meant to draw on like the similarities between like with other languages in a way it's meant to be easy to learn. It's also cross-platform, so you can use it on Windows, Linux, Unix, Mac, pretty much whatever system you have available, you can download and use Python. It's also object-oriented, which means that it supports the building of classes, objects, everything that's a part of object-oriented programming. If you don't have any experience in this or don't know what it is yet, that's fine. We will be covering this to some degree. We'll give you a sense as to what's available within object-oriented programming in the coming weeks. And another big thing is that Python can actually be integrated with other programming languages. So if you do have experience with other programming languages or know folks who do, Python's kind of like a great middle ground for communication. So if you have folks that work in, I don't know, Ruby, Java, whatever else, Python can in some ways serve as like the common denominator, or at least like a common language for many different people and many different disciplines. So we're going to spend some time today actually getting the environments that you need to interact with Python and getting a sense as to what the most basic environment is, which is actually, it's called idle. It's basically the Python shell. So if you're familiar with what programming environments look like, there are a lot of tools to make working with programming languages easier. But the most bare bones tool that you can use to write code is the shell like this. So the Python shell is called idle, interactive development. I don't remember what it's called. We'll look it up on the actual website. But this is the cleanest, simplest way to write Python code, especially if maybe you have an older machine that can't download. Okay, someone asked if I can make the presentation full screen. I can. It's a little bit wonky with Zoom. Like it makes it difficult for me to keep track of questions, but I will keep this full screen as long as possible. Thank you. And yeah, so this is the simplest way to actually write Python code. And we're actually going to go ahead in a moment once I show you some of the other environments and just go ahead and download it. The next tool that I strongly recommend that you use if you're going to be working with Python in your local environment, which basically just means your computer. So when I say local environment, that means you're working on your computer. You're not working on a cloud. You're not working on DataCamp's small machine where you can actually practice in the console. Like you're working on your desktop and maybe writing a few scripts to process some Excel files, analyze some data, look at some numbers. Like this is absolutely your tool of choice. So Anaconda is the most commonly used open source platform for Python data science. Okay. Okay, someone said they can't see my screen. Is that true for everyone else? Okay, can folks see my screen? Okay, so one person cannot see my screen, but everybody else can. Okay, can you actually try refreshing your Zoom for the person who cannot see the screens, because everybody else says that they can. Okay. I'm going to continue for now. We are also going to be distributing the slides at the end. So if there's any part of this that you can't see, I'll make sure that you have all of the materials available to you at the end of this session. But yeah, Anaconda is a distribution. So in essence, it's a set of tools built on top of the Python environment to make it easier to write code, evaluate your code, make sense of the results for whatever purpose that you need it for. There are a lot of tools within Anaconda that are available. As you can see, this is basically what the Anaconda Navigator looks like, and we're going to actually open it and take a look at what's available through there. There are a number of just different things that you do with these tools. So for example, Spider is an interactive environment where you can keep track of just different things that are going on in a larger data science or coding project. I use it pretty much every day in my own work as a data scientist. There's also Jupyter Notebooks and Jupyter Lab, which is also an absolutely essential tool to get familiar with as a data scientist. And that's okay if you don't have any experience in any of this. We're going to get familiar with it today. That's what this session's about. And like I said, there are a number of other tools here. So like Jupyter Notebook, Jupyter Lab, we'll talk about those shortly. There are some other console environments. Feel free to explore them. The three that we're going to probably be using, or the two that we're going to be using the most are Spider and Jupyter Lab. Someone asked a question about an interactive development, an IDE, or interactive development environment called PyCharm. PyCharm is also a great tool. We're actually not going to be using it for the duration of this course. Like I said, there are a number of tools that are available to you within the Python environment. PyCharm is one that's great if you're writing longer pieces of code. So if you're actually like writing maybe a very long script, web scrape, like writing a web scraper that's maybe several hundred lines or something, it's a great way to keep track of just what's going on in very complex coding projects. Maybe tell you where errors are beforehand. Yeah, so PyCharm's good for coding projects. I personally don't use it very often because it's not quite what I do, and it's not quite as helpful for what I do on a day-to-day basis, but I absolutely recommend that you try it. PyCharm's a great interface as well. Someone else asked a question. Are there any differences in libraries, packages between Jupyter Notebook and Spider/Python? So if you're not familiar with the Python environment, in essence, we're going to cover this a little bit shortly, but there are a number of just basic operations that the bare bones versions of Python can do. So like you can write certain types of like blocks of code, you can write for loops, you can write mathematical equations, you can do a lot of different things within Python without anything extra being installed on top. There are also a number of what's called libraries or packages that are available to you through Python. Many of them are built in. Like for example, we're going to talk about the NumPy package a lot, which is a lot of mathematical, basically just easy mathematical computations. So for example, if you have a series of numbers, maybe you have like stock prices over the course of 10 years or something. And if you had it on a graph, like you could see that prices probably go up. Let's say you wanted to take a logarithm of those numbers with like the base Python and nothing installed. You could write out the equation to calculate it manually. NumPy instead has a function where you can just do like log 10 and then, or log whatever base you want to do, and then just calculate the log of all of those numbers. And the basic packages are available in both like the normal, like the basic Python environment. They're available in Spider. They're also available in Jupyter. You can also install packages in any of those environments as well, like more advanced ones, maybe like TensorFlow if you're looking into creating neural networks or deep learning models or just more advanced stuff. Yeah, you can install those in either Jupyter Notebook, or you can install them at the terminal using a package manager to be available to you within Spider. So I want to take a second. If anybody has any questions, please feel free to drop them into the Q&A. I will be answering them periodically as they come, and then sometimes I will also just be taking time after each section to answer your questions, but I am actively monitoring how I can support you in making sure that this material is relevant to you. Okay, so the next thing, and we've talked a little bit about Spider. This is just a quick reference for what that environment looks like. We're actually going to dive into that ourselves. Spider is a really robust tool for working with Python for data science because it allows you to keep track of a lot of things that are going on. In the basic console, you put in code, you get an output. Here, you can keep track of a lot of different things that are going on. Maybe larger Python scripts. Let's say you're analyzing a very large data set. This is actually an example of a machine learning model that I was building to classify a number of buildings in New York City based on whether or not they're residential or commercial from a number of characteristics about them. And here I can keep track of a lot of things that I've done in the past and basically keep a record of all the work that I've done. In this side, which is the editor, so you can write like large scripts. On the top right here, I have what's called a variable explorer. So I have a list of everything that I have saved. So in this case, it tells me here are the data sets that I've loaded in. Here are maybe like any functions that I've written or any objects that I've created. Anything that I've assigned or saved within this session will be available in the variable editor or the variable explorer here. And then on the bottom right, we have the console, which is where you see the code that you've run at any given time. So let's say I want to run 10 separate calculations. It'll keep track of here's what I just ran, and here's the output, and then here's what I ran, and here's the next output. Basically, it's really good for record keeping and larger projects. And then finally, there's Jupyter Notebooks, which is, I think, very often the final step in which you share your work. If you've taken a look at anything, a lot of times you'll see, for example, articles on Medium or Toward Data Science that do tutorials of different topics, where you have maybe a paragraph describing what's going on, and then a little section where there's code, and then another section where there's an output showing the result of the code. Jupyter Notebooks / Jupyter Lab is basically your tool of choice for that. So it's all of this is open source, so it's free to download, and it's a great tool for building a portfolio, for sharing live code, equations, visualizations, and also describing what you're doing, because describing what you're doing is just as important as doing the task. Like, you need to actually explain to people around you what type of analysis you're conducting, why you're doing it, what the results are, and how you're interpreting it. And as you'll see, these are just text blocks, these are code blocks, and then these are the output of those code blocks. And we'll talk more about what is actually in each of these cells. Does anybody have any questions so far? I'm going to give it like 10 seconds if anyone's typing out a question. Okay, if not, then we're going to move on to the next section. So you can navigate, so you'll download Jupyter Lab through the Anaconda distribution. That's the best way to do it. It's available through there. You can launch it. Like the first time around, it may tell you to install it. You'll notice where I have circled, it says launch, and then some of the others it says install. That gives you an idea as to what I tend to install in my own environment because I took the screenshot. So you can it'll install it, and then you can launch it. But we'll cover a number of ways in which you can actually open and access Jupyter Lab both in and outside of Anaconda. Okay, and like I said, you'll also notice it's Jupyter Notebook and Jupyter Lab. Jupyter Notebook is just the equivalent of a single Word document. Jupyter Lab is just an environment where you can open multiple notebooks at once. Okay, so let's actually jump into downloading everything. So if you're downloading the basic Python environment, which is, I would say the first, if you haven't worked with Python before, I strongly recommend you start here just to get a sense as to what the basic console looks like within Python. You may not actually end up using it very often. I know that I don't. But it is worth the effort to get comfortable in a basic shell environment and what that looks like and what's available to you, and also just why you might want to choose one of the more complex tools over just working with a basic, just like a basic shell. So you can download Python. We're up to 3.7.4. You can download the latest version for your system. As you can see, I'm on a Mac, and it'll auto detect what system you're on, and then just make sure that you download the correct system for whatever type of machine that you will be working on for the duration of this course, or just what computer you have that you work with Python on for as long as you choose. So Windows, Linux / Unix, Mac, or others. In this case, I've already downloaded it. The shell is a pretty light download. When you actually install it, the program that you're going to be working with is not called like Python. It's actually called idle. So the interactive shell, when you actually open it, it is just going to look like this. So you get a very basic message when you first open it up, tells you the time that you opened it, what version you're on, and then if you want to get some more information, so you can type help, and then you get a like some different information about based on whatever you want help. But you'll also notice that it's pretty simple and that there is input and output. You type something, you get a response. So you can do 3 + 3, you get 6. Hi, you get hi. And then you just immediately get the output, which is great. But a lot of times you may want to work on bigger complex projects where you don't immediately just want the output. You may want to write larger blocks of code, plan out for what you want to do later, keep track of what you've done in the past. And this kind of tool isn't that great for it. So that's where Anaconda comes in. I'm going to see where I installed it. I believe I just did, so there we go. Anaconda Navigator. When you install it, it's a pretty big install. It's something like 600 or maybe like 600 megabytes. So I went ahead and installed it ahead of time. And the Anaconda Navigator looks like this. It's basically what this is a hub for a bunch of different tools that you could use with Python. And anytime that you open the actual Navigator, it's simply the window to choose your specific tool of choice. So I'm actually going to launch Spyder, which is Spyder's the scientific Python development environment. This, again, is my tool of choice if I'm working on a local computer, because it's a great way to keep track of a lot of different things that are going on. And I want to cover a couple of basic things here around, no, I'm not going to install. I want to cover some basic things around how to interact with such an environment. So this is a script. You can literally write anything here you want, but the goal is to write Python code, because otherwise it won't work. You'll notice that I wrote something that wasn't actually code, and then immediately I was told that it's valid syntax. So that's where this type of thing comes in handy, gives you some ideas as to where there may be some basic errors in your code. And that's actually the first thing I'll tell you is if you haven't done any type of programming before, you're going to run into code errors. So I actually got a very important question here, which was, if we download Anaconda, do we need to download Python? No, I don't believe you do. There's no prerequisite. You actually get what you need just from, like, if you don't want to download the Python shell, you can just download Anaconda. I still just recommend that you do both, because it is absolutely worth getting familiar with the shell. Like, it is useful, especially as you grow in terms of programming. You will be working with the command line or the terminal or whatnot more often. And it's a very similar environment. So more than anything, I think it's useful for practice. Okay, so I'm going to show you very quickly just a couple of things that you can do in such an environment. So again, you can print things, but by typing this out and hitting enter, nothing happens. You actually need to select the portions of code that you want to run and then run them. So in this case, I can hit run file. It'll run everything that's in the file. I can also, I think it's Control Enter is just print out the section of code that you have highlighted. You can also, again, write more complex code. So I'm going to make this shorter. You'll notice this is basically a for loop. And like I said, Python indents stuff, which means that anything that's indented is considered part of this block of code. You don't need to worry about what this means yet. In essence, what I wrote was for every element in between the numbers 0 and 3, print them out one at a time. This is actually what we're going to be covering next week, but just to give you an idea as to what Python syntax looks like, anything that's part of the same executable block gets indented, like it actually needs to be indented. If you don't, yeah, it expects an indent, like it is necessary for it to run. And then another thing I also want to quickly cover is, and I would actually ask this question of folks in the chat, who here knows what a working directory is? I know a couple of you said that you have some experience in programming, some some previous experience with different programming languages. Who knows what a working directory is and who doesn't? Okay, got one person who says they don't know. So we're actually going to cover this very early on because this was a question that I've seen come up in the past. In essence, when you're doing any type of programming task, your environment, so in this case like Spider, will default to thinking or like picking a folder that you're in. So in essence, your working directory is the folder that you're working out of or the environment in your machine that you're working out of. So you'll notice here, it started off as a default in user/Mona, which is my name, like my computer name. And then in the Spider folder. What you will very often have to do is navigate to a different environment in order to work with the files that you want. So I'm going to actually show you what that looks like quickly. If you're, for example, if you're working out of a folder where you have a bunch of maybe like 2 CSVs that you'd like to load into the Python environment to do some analysis, you need to locate them properly in order for things to actually load. So in this case, I'm going to navigate to Documents, Emeritus, Intro to Python, and then hit Open. And now what I've done is I've changed my working directory. So in essence, now I have, now I'm in this folder, and everything that's in this folder is easily available for me to run. So for example, I have a number of CSVs in here, and some of them, like we're going to cover this later on, but so sdds data.csv. That's what it was called. No. So now I've imported a packet, like a library, and I'm just going to read in the CSV. Boom. And then now what's available in the Variable Explorer is I have a data set. But it only reads it like this if you're in the proper working directory. If I were in a different working directory, I need to actually, like let's say that I was in a different folder. What I would actually need to do is specify where this file is for me to load it properly. And it would usually looks like this. We're going to cover that a little bit later on. But I know this was a question that came up in previous sessions, so I want to make sure everybody's clear on just what a working directory is. With Python or with pretty much any programming environment, you need to specify where your files are and where you're working from. Otherwise, you'll end up saving things on your desktop in a temporary folder, or just not being able to find and open the files that you need. Okay, does anyone have any questions so far? Okay, so the next thing we're actually going to do is we're going to jump into the JupyterLab environment. And there are 2 ways to do this. You can launch JupyterLab from Anaconda Navigator, which is absolutely valid way to do that. In essence, what it will do is then open a browser tab in whatever your default browser is and open up JupyterLab. You can also open it from the command line or the terminal, which that's my preferred way of doing it. It is entirely up to you. So in this case, I'm actually in the folder that I want to. So oh, okay, I don't have it installed on the command line. So we're actually just I think it's pip3. So I'll take care of this and show you later on, but in essence, I'm attempting to install JupyterLab. Oh, that's why. There you go. So you can do that from the command line. That makes it available to you to use outside of the Anaconda distribution. And this, what I'm working here is actually the terminal on Mac. If you're on a Windows machine, I believe it's called the console, but in essence, this is the command line. So where you actually just type in simple commands around like navigating, installing things, opening things. And then just with typing out the words JupyterLab, I've then opened up JupyterLab. So you'll notice I have a lot in here, and we're actually going to cover a lot of these different materials throughout the duration of this class. But let's actually jump into the first notebook, which like the first Jupyter notebook for this class. So in essence, this is a special type of Python file that's it's basic an IPy. It's called an IPy notebook. Anytime you see a file extension that's .ipynb, that's a Jupyter notebook. And this is a JSON file with Python code wrapped into cells. And you can upload these to GitHub. You can upload them to Kaggle. You can upload them with basically like you can upload them showing the descriptive text, which is a section like this. You can show the sections of code and then the output associated with those sections of code. It makes for a great portfolio piece. And you're probably going to notice this as you start looking up different Python tutorials, finding ways of solving more complex data science problems. You'll notice this type of framework. It's all basically like a Jupyter notebook of some kind. So let's actually get started. I have a number of things I'd love to cover that I actually have in this notebook. And I want to give you a sense first as to just what is available, what I'm doing in this notebook. So you have a lot of different commands here. Some of them are pretty obvious. You save, you can cut pieces of text, you copy, paste, you run, you stop the cell, or you restart the cell. And then this specifies what type of cell this is. So anytime you see a blue line here, this means I have selected the cell, like this cell. Like every unit of information, every unit of text code, blah, 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 is a cell. So in this case, I'm double clicking it, which now means I can edit it. And this is what's called a markdown cell. Markdown is a common way of formatting text that you'll probably be exposed to a lot if you work with GitHub. It's becoming more and more common just in terms of a way to format things. And I've included a link to a Markdown cheat sheet, which gives you a sense as to like which codes allow you to bold, italicize, underline, bullet point, or create headings. And this is pretty much universal and you'll run into this a lot. So what I have here when I double clicked into this is I'm now editing this cell. If I want this text cell to be done and I don't want to touch it anymore and I want to present it, I hit run, and then it just gives me formatted text. The next type of cell is, this is a coding cell, or a code cell. You'll notice markdown code right here, it keeps changing. This code cell, I can run independently from all other code cells in here, and I can I'm going to clear all the outputs so we can actually start from scratch. But this prints out 3 different things. You'll notice if you start a line with a hash, that turns it into a comment. There are a number of ways in which you can print things to the console, and you'll be printing things a lot. You can print things using single quotes. You can print things using double quotes. These are useful, like if you want to print a string of text that maybe has an apostrophe in it, surrounded with double quotes. There you go. Whereas in this case, as you can see now, it's black again, which means this part isn't being recognized as quotable text. And if I were to try to run the first one, I'd get an error. We'll talk a little bit about how to make sense of errors as we go, because the first thing to realize is you'll probably never stop getting errors in your code. You just get better at dealing with them and figuring out how to solve the problem. So I've printed out two types of text, and I've printed out the sum of two numbers. So you can print pretty much anything. Showing results as an output is usually done by printing. So you can also assign objects in Python. So anytime you create something within maybe like an arbitrary word, in this case, I'm creating an object called a greeting. And then I had an equal sign, which means I want this new object called greeting to equal this stuff on the other side of the equal sign. So in this case, it's just a phrase. So hello and welcome to the course. And then I can print the greeting. And if I change it, it prints a new one. Just something to keep in mind, because most of what you're actually going to be reading into your Python environment is stuff that you're going to be assigning to some type of object like this. So if you read in a data set, maybe an Excel sheet where you have a bunch of numbers, like some accounting numbers or finance numbers or any type of record that you want to take a look at, you'll be reading it in, but the way in which you then access it and maybe compute some averages, do some type of analyses is by performing operations on the object that you actually read it and saved it to. So you can name your object anything, just don't name it keywords. Keywords come up in green. So like a for loop, for example, while, print, like you don't want to call your object print, for example, because that's, yeah, just don't do that. Call it anything arbitrary, probably something that's relevant to the work that you're doing, and then you can reference it later on. You can also print an object with numbers. So in this case, I've assigned the letter A is equal to the value of 94, B is equal to the value of 12, and then you can add them together. You can subtract them. You can do a whole lot of different operations on like numerical values. You can also add strings. So I think we actually cover that later. There, and then it just concatenates them and puts them together. And you'll notice what I actually did here is I threw a hash. That's a great way of just not running a specific line of code, where like instead of having to delete it, I then just turned it into a comment so it's not going to do anything. And then you can turn it back. It's a great way of just not destroying your code or deleting things. There are also a number of variable types that are relevant within Python that we're going to be building upon. And everything that you will interact with in the Python environment is built on top of these 4 types of native variable types, which means that just the basic Python recognizes these 4 different types of objects: integers, floats, strings, and booleans. So an integer is a whole number. Basically, it's just a number without any decimal points. Anything from 0 to whatever infinite number of digits you want to throw into it. As long as it doesn't have a decimal point, it's an integer. You also have floats, which is numbers with a decimal point, and those get treated a little bit differently. Depending on what you're looking at, many times it may not make a difference. Like you can take averages of integers. You can truncate your floats to only, or round up or round down to only be a whole number. but technically two different types. So then print the type, like you also then have strings. Strings are contained either within single or double quotes like we covered earlier. You'll see a mixture of the two. I've seen some preference for single quotes, but it really, like, I think it's fine as long as you're being consistent. The fourth native type is called a Boolean, which is a true or a false. So this does have to be specified, like the first letter has to be capitalized, otherwise it doesn't recognize it as a Boolean. And let's print out the types. So the last one's called a bool. So you can do a lot of different things to these different data types, and we'll cover that a little bit. So you'll notice here that, like, the reason that I'm specifying that we use the print statement is because print allows you to print out multiple things within one cell. If you just did type and I took out the print, it'll only print out, like, it'll only return the output from the latest thing that produces an output and then ignore everything else in the cell. And depending on what you're doing, you know, I could have 4 different cells here, but that will probably get messy. So print is a great way of just organizing and then printing out one piece after another, whatever output that you care about. Does anyone have any questions so far? All right, I'm going to keep going. If anyone has any questions, please put them in the Q&A, and we will address them as we go. So, like I said, you can perform mathematical operations on any type of data type, including Boolean, and you'll get different results based on what you're doing. So, if you print out 3 plus 5, you'll get an integer 8. If you print out like the addition of 2 different floats, you'll get a float. If you print out strings, it'll just concatenate them together. And then if you add, you can actually add, subtract, you can do mathematical operations on Booleans. A true is treated as a 1, and a false is treated as a 0. So you can add them together, average them, sum, divide, whatever is relevant to the question that you're answering. Okay, so someone had a question. I'm going to start answering the question since we got a number. Or we got a number of questions. Can you explain again why I didn't print string and Boolean? Do you mean here in this cell? So in this case, this is a bit more of a technical difference between printing and returning. In this case, what it's doing is returning the last line of code in this cell that produces an output. Print will make sure that anything that could potentially produce an output will appear on your screen. Without it, it'll only select the last one that is possible to return an output. Okay. Someone asked, is this document available in JupyterLab, or is it created by you for the learning purpose? So I actually created this document. We will be sharing it around with the slides at the end of this webinar, which is part of why we strongly recommend that you install JupyterLab, so you can then interact with this notebook on your own, edit it, add to it, and play around with just what's possible in the JupyterLab environment. And someone else asked, what will you be covering in this webinar? In this specific session of the webinar, we are covering basics. Starting next week, we're going to be covering Python for data science, analytics, and a number of different case studies around visualization, statistics. Those are all in the in the syllabus for this class. And I'm absolutely open to taking requests on maybe specific data sets that you guys want to take a look at, questions that you're interested in, some domain knowledge that you have that you'd like to look at further. But right now we're really just setting the foundation to make sure everybody's on the same page in terms of what we'll be doing within Python. Okay. And like pretty much any programming language, if you've ever worked in R, or if you worked in Excel, you'll know that you can perform mathematical operations. Just keep in mind that this is what the syntax of different operations looks like. You can subtract with the minus sign, multiplication is a single star, division is a /. So 4 divided by 2 is 2, and that's the division. And this is an exponent. If you want to denote an exponent, you use a double star. There you go. And these are the outputs that you get just from the different mathematical calculations. This will come in handy a lot when we're starting to look at complex data sets and maybe doing transformations, creating new features. A lot of times figuring out features for machine learning models is simply a complex mathematical transformation of the data that you have. So you will be using these skills on the regular within data science. And then again, you can add, subtract, multiply, and divide Booleans, and it's literally like it treats it as a 1 and a 0. So any rules that apply for basic mathematics that involve 1s and 0s apply for true and falses. Okay, and then what do you think happens if we multiply these two right here? So we have A, which is a string called hi, and then we have B, which is the number 9. Does anyone want to share in the chat what they think will happen if we multiply this string by this number? Okay, someone says an error, 2 errors. Someone said hi, 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 hi. I've got 3, okay, a bunch of errors, and then someone who said we're gonna get the string hi 9 times. Let's take a look. Python will actually just take the string and repeat it 9 times. So just something to keep in mind in terms of how Python deals with mathematics that involve things that aren't numbers. So we're also going to very quickly talk about errors, and this is a skill to take into any type of programming that you do, which is how do you deal with different errors that you will get. Some programming languages are better about explaining what the error is, where it is, and why you're getting it. Some of them are a little bit more opaque in terms of what information they provide you. So Python can occasionally be a little bit general in what its error messages mean. In fact, if you actually look at programming communities, they often make fun of it. Python just told you this is invalid syntax. Doesn't necessarily tell you why, what you're missing. There are some contexts where you may get more information about what's missing. But in this case, it doesn't. We just see that there is invalid syntax approximately in this position. So when dealing with errors, the best place to start is see where it's pointing to. Almost a lot of times your errors will be because of quotes, semicolons, parentheses, brackets, commas, quotations, yeah, stuff like that. Like that's a very common list of reasons for having errors. So first, just if you see an error, make sure you got your punctuation correct and go back and correct it. We're going to keep the error. In this case, we're going to take the same A and B and then try to do A to the exponent to the power of B, and we're going to get an error. So this is where the limit of mathematical operations with strings goes. You can't take hi to the power of 9. And you get what's called a type error. So this was called a syntax error, which just means you typed something wrong. This is called a type error, which means something about the data types that you have does not support the operation you want to do. And then you can print nothing, which just gives you nothing. But one thing to keep in mind is that if you are dealing with errors, take a look at first what the type of the error is, take a look at what line of code it's pointing to. And if you really can't figure it out, Google your errors. you are not the only person learning Python. You're not the only person who's Googling their errors. Like, the best thing that you can do as a data scientist is figure out how to handle your errors. There will never be a point in your career where you don't have them. So in this case, I could Google type error. The first results that you're going to get usually are from Stack Overflow, and Stack Overflow is a great resource to keep available to yourself. Yeah, you can learn so much from Stack Overflow. It's a great, like, Google your errors. It's a great resource. You'll often find people Googling similar problems, maybe also just frustrated about what they're dealing with something that's not working. And then people who jump in and respond to questions if they have a solution to the error. And the latter part is actually a great thing for you to do in your own career, is as you start figuring things out, go and see if you can help people answer questions, because I think you get points for them on Stack Overflow. They have a jobs board. It really is a useful resource for building your career as a data scientist. Is go and contribute to the community, help people solve their problems with their code, and read and contribute. But yeah, error handling, we're starting with error handling because it is absolutely necessary to deal with the errors that you deal with, that you will encounter throughout your data science journey. You'll get similar errors sometimes on your data camp exercises. This applies to those as well. So if you're completing a data camp exercise and getting a type error or syntax error, it probably has like in the console, like if you get like a return error on data camp, like data camp's little console, that means that it's an error related to something in your code. They also have their own custom error messages, but if you see something like a syntax or a type error, you can Google that too. So that's actually it in terms of covering the basics today. I want to make sure that we have some time to answer any lingering questions. But my request to you is that before the next class, you have Anaconda and Jupyter Lab set up so that you can then download and interact with all of the Jupyter notebooks that we have written for this class, and then go and practice on your own. This is how you follow along with the materials. Okay, does anyone have any questions? Okay, and then as you're installing and testing out the different basics within Python, please feel free to send me a message. Please feel free to send Kaz, if he's your course leader, a message as well as sharing in the discussion board. The discussion board is where you also have the opportunity to ask questions and contribute to answering questions as well. So there are no set office hours. Our request is that you set up a meeting with your course leader, because we've had office hours in the past and we found that that's been very difficult since folks are from a gazillion different time zones. And we simply we were able to find workable times for most people. So yeah, my request is that you set up a time individually with your course leader. Okay, well, thank you. Yeah, so apart from the installation, that's it. Just go ahead and start playing around with Jupyter Lab, get familiar with the environment. Feel free to go through the actual notebook and run it yourself, maybe make some changes. But that's all you need to do before, that's what you need to do. That plus the data camp courses. Okay, yeah, I don't know why my mic went quiet. Okay, yeah, I'm not sure what's wrong. Let me cut this off. Okay, so this is going to sound a little weird for a sec because I'm just on my computer microphone, but that's pretty much it. Complete the relevant data camp course for this week. Have the environment set up, and please feel free to reach out to your course leader before the next session. And that's it on my end. And thank you very much for attending. Okay, so someone had just said that they have questions. Can you please send me, or if you're in causes section, can you send your course leader an email with your questions? I'll make sure that you have time set up to have all of your questions answered. All right, and thank you all for attending. And I look forward to seeing you in the next webinar. Alrighty, I am complete with this session, so program support, you're welcome to end the session when you're ready.
Hello. Thanks, Mona.
Thank you.
All right. Well, if you can just send in the slides, that'd be great. I'll be stopping the recording and the YouTube as well. All right.
Got it. Thank you.
Perfect.